movie 4.4. So sometimes we want to combine conditions together. For example, if it's raining and I'm going outside, then I need to pick up my umbrella. Now we could nest these together with two if statements, one inside the other. So say if it's raining, then I enter this next region, if you like, go into another room. If I'm going outside, then pick up my umbrella. But it's much more elegant to join them together with what we call the logical AND operator. So the logical AND operator is one example of a Boolean operator, and these take in one or more things, that is operands, and compare them, only this time they're not using arithmetic comparisons, but the logical true-false values. And these are the basic building blocks of computer logic. So if you look at a computer chip in enough fine-grained detail, you will basically see that the chip is made up of lots and lots of very simple logic gates like NOT and OR and so on. So the AND operator is only true if all of its operands, that is all of its inputs, are true. And the OR operator is true if any of its operands are true. That is, if any of the inputs to an OR operator are true, then the OR operator outputs true. NOT simply takes a single operand and flips it from true to false and vice versa. So hopefully you're familiar already with Boolean logic. If you're not, or if you just need a refresher, then I've linked on Blackboard to a tutorial. But the logical operators are basically used to combine or chain conditions together. So we can say if something and something else is true, or something else is false, and so on. So the logical AND operator is denoted in processing and in Java and in C and C++ and all that family of languages by the double ampersand. Okay, so that's the notation that we use for logical AND. So if some condition is true and some condition, then do something else. So how do we actually go about using this? So here's an example problem. We might want to say something like, if the mouse pointer, and remember how we access that, if the mouse pointer is in the bottom right hand corner of the screen, then draw a rectangle filling that region. So what's our basic algorithm? How do we encode the idea of bottom right hand corner if we know the width and the height of the canvas? So what I want you to do is pause the movie, have a think, maybe sketch out a canvas on a piece of paper, outline the bottom right hand corner, and hopefully the idea should be clear. So pause the movie, have a think, and then come back. Well, we really only want to do something if the mouse pointer X is over halfway across to the right and the mouse pointer Y is over halfway down the canvas. So we can write this as mouse X is greater than width divided by 2 and mouse Y is greater than height divided by 2. So remember, the origin is at the top left. So hopefully this diagram will make things a bit more clear. But now we want to, so basically if the mouse pointer X is greater than the width divided by 2 and the mouse pointer Y is greater than height divided by 2, so essentially this is like almost like a Venn diagram of that. Okay, it's this region here. So now we want to explicitly draw a rectangle in this region. Now we haven't yet covered how to do that, so let's talk about that now. There's a built-in function in processing called rect, R-E-C-T, that takes in 4 arguments. It takes in the coordinates of the top left of the rectangle, the x and y, its width and its height. So the rect function takes in 4 pieces of information: a point, x and y, which is the top left of the rectangle, and the rectangle's width and height. So how would we specify a rectangle occupying this bit of the canvas given that we know what the width and the height are? So pause the movie, have a think, and come back. Okay, well, clearly the top left of the rectangle is right in the middle of the canvas, so its x-coordinate is obviously width divided by 2, and its y is height divided by 2. And then again, the width of the rectangle is width divided by 2, and the height of the rectangle is height divided by 2. So here's the code to achieve what we want to, and it's on Blackboard as southeast. So every time around the draw loop, okay, we clear the background to be, in this case, blue, so RGB, all blue, and then we look at the mouse pointer. So only if the mouse X is more than halfway across the screen, and there's the logical and there, and mouse Y is greater than height divided by 2. So if both of these things have to be true, then we set the fill color to black and we draw the rectangle. So here we draw a rectangle that has its x and y. Top left x and y is width over 2, height over 2, so that's the top left of the rectangle, and its width is width divided by 2, and its height is height divided by 2. So remember, width and height here don't refer to the width of this rectangle. Width here refers to the width of the canvas, and height refers to the height of the canvas here. Okay, so hopefully that's all clear, and this is the rect function that comes pre-supplied with processing. Now, you'll recall that we earlier mentioned the not operator. So sometimes we want to do an action where something is not true. That is, if it's sunny and we're not working, then let's go to the beach. And as we said, not is denoted by the exclamation mark, or called the bang. So how might we use this to, for example, build a program that draws a shape wherever the mouse pointer is? So if the mouse button is not pressed, then we draw a green circle. I'll show this working here. So we move the mouse pointer around, and if the mouse button is not pressed, then by default we draw a green circle. Otherwise we draw a red square, and here it is working. Okay, so here's the pseudocode. So looping forever in draw, we simply clear the background. So if the mouse is not pressed, then we draw a green circle at the current mouse location. Otherwise, else we draw a red square. So whenever the mouse button is pressed, we draw a green circle, and if it's not pressed, we draw a red circle. And we just do this forever. So here's the code. It's on Blackboard as southeast. So every time around the draw loop, we clear the background to black, and then if the mouse sorry, I'm talking about the previous slide. We clear the background to black, and then we use an additional inbuilt variable which is called mouse pressed. So you remember we've got these variables for mouse X and mouse Y. Here we've got an additional variable which the system looks after for us, and just watches the mouse button. So if mouse pressed is true, has the value true, then the mouse button is currently being pressed. So if not mouse pressed is basically the same as saying if mouse pressed is equal to false. So if the first evaluation is true, that is mouse pressed is not true, then we draw a circle in green. So here we see fill everything as green, and then draw a circle centered on the current location of the mouse pointer. Otherwise, if it's not true, then we set the color to red, and we draw the rectangle, not centered but located with its top left at the current mouse pointer location. So you might notice something odd about where the rectangle is drawn relative to the mouse pointer, and if you're confident with the material so far and you want to investigate this in a bit more depth, then there's a link to follow. Otherwise, don't worry too much about it because it's not that important. So sometimes we want to say if something is true or something else is true, then do this. So if it's sunny or it's the weekend, then I'll wear a t-shirt. So we use the logical OR operator to do this, which is denoted by these two vertical bars, which at least on my Mac keyboard, these are above the backslash character next to the return key. So how would we add to this southeast rectangle program that we've previously looked at to add an additional feature? That is, if the mouse pointer is in the bottom right hand corner or the mouse is pressed, then we draw the rectangle. So we're adding an additional feature where if the mouse pointer moves to the bottom right or the mouse is pressed, then we draw the rectangle. So what I want you to do is bring up the code for southeast into processing and have a think about how you might modify the code to include this feature. So clearly you have to add something to the if statement, but what? So pause the movie, have a think, try it out yourself, and then I'll come back with the answer. So the only change that we need to make to the if statement is adding an additional condition here. So we've got the spatial requirement here about the mouse pointer. That hasn't changed, okay? But we've added this additional condition which basically says if this spatial condition is met or the mouse is pressed, and this essentially is the same as saying if mouse press has the value true, then we draw the rectangle. And you'll notice how we've separated out the spatial condition from the mouse condition using the brackets. Okay, and this is good practice, like bracketing off parts of an equation in order to ensure that it's evaluated correctly, and it also makes it easier to read, I think.